Okay, guys, so here we are at our radical quiz study guide. I'm just going to kind of go through these problems. So the square root of 64, that's a perfect square. That would be 8. The cube root of 8, if hopefully you keep that list of cube roots handy, that will be really, really helpful. And the cube root of 8 would be 2. So when I add 8 plus 2, I would end up with 10, and that's your answer. Okay, so again, the square root of 144 is 12. The cube root of negative 216 is going to be negative 6. Remember that if it's ever an odd exponent, like 3, 5, 7, 9, anything odd, it can always be negative. So if I were to add 12 and negative 6, I would end up with a positive 6. All right, here we would want to take a look at this if this were the square root of 49 and the square root of 25. And the square root of 49 is 7, and the square root of 29 is 5. So our answer would simply be 7 over 5. All right, and for number 4, I would take the cube root of negative 1 and the cube root of 27. And the cube root of negative 1 is still negative 1. And the cube root of 27 is 3. So my answer would be negative 1 over 3. Okay, square root of 54, that's not a perfect square, so we try to think of the biggest perfect square that goes into 54, which would be 9 and 6. All right, well, 9 is a perfect square, right? It's 3 and 3, so that would be the pair that would come out. 3, it can be factored further, but there's no more perfect squares, so our answer would simply stay 3 rad 6. Same thing with 24. All right, the square root, the biggest perfect square that can go into 24 would be 4 and 6. And we know that 6 can't be simplified any further, but 4, the square root of 4 is 2 and 2, or just 2. So our answer would be 2 rad 6. All right, down here, we got a lot of 4's to mess with. Our biggest perfect square that can go into 40 is 4. 4 times 10. Well, the square root of 4 is 2. We need a pair, right? So that pair comes out 2, and 10 can't be simplified any further. So our answer is simply 2 rad 10. Okay, well, this is where things get a little bit tricky. And remember, if you paid attention to the videos, I had you guys break them apart. So rad 28, rad x to the 5th, and rad y to the 8th. So biggest perfect square that can go into 28 would be 4 and 7. Well, the square root of 4 is 2, so it would be 2 rad 7, right? Square root of 4 is 2, 2 and 2. All right, and then for these, we simply take this number, 5, whatever exponent's raised to, and divide it by whatever we're rooting it by. So in this case, 2. 5 divided by 2 is 2 with a remainder of 1, which means that x squared, right, because there's a 2, would come out, and we'd be left with 1x left inside. And here again, we would have 8 divided by 2, which would be 4. So there would be nothing left over. So y to the 4th would come out. And we simply multiply those back by each other. So 2 times x to the 2nd times y to the 4th. And whatever was in that radical will stay in that radical. So 7x. And that is number 8. So for number 9, we're going to kind of do the same thing. So we're going to break it apart where we have 200, a to the 4th, and b. All right, well, we'll think of the biggest perfect square that can go into 200, and that would be 100. The square root of 100 is simply 10, and 100 times 2. So we have 10 rad 2 is the square root of 200. And then here we're going to do 4. We're going to divide it by 2, which is 2. So we'll have a to the 2nd. And this one would be 1. 1 divided by 2, which you can't really do, so we would still just have b in its square root by itself. We would go ahead and multiply whatever is left over here. So a to the second times 10 is 10a to the second. Nothing else was left outside of the radical, so we end up with 2b inside. Okay, so now we have a cube root, so things get a little bit trickier. We're going to go ahead and take the cube root of 16, the cube root of x to the 5th, the cube root of w to the 6th, the cube root of y to the 2nd. All right, well, the cube root, if you remember, of 16 would simply be 2. All right, for this one, we're going to do 5 divided by 3, which is going to be 1 remainder 2. So that means I would have 1x come out, and x squared would stay inside. Here I would have 6 divided by 3, which is 2. So I would have w squared come out. And here I would have 2 divided by 3, which I can't do, so y to the 2nd stays inside of the radical. Now we multiply everything that's on the outside, so 2 times x times w squared, and then the square root of x squared, or cube root, sorry, not square root, cube root of x squared, y to the 2nd. All right, so then we move on to number 11. Okay, so remember, whatever's on the bottom, that's the root we're going to be taking. So this is going to be the cube root of 8, and then whatever number's on top, that's what we're going to be squaring or raising it to, whatever power we're raising it to. So the cube root of 8 is 2, and we're going to square and then we're going to take 2 and raise it to the 4th power, which would be 16. Okay, so same thing here. We're going to look at our denominator, and it's a square root this time. So we're going to do a square root, and then right here, our exponent, we're going to raise it to the first. So 36 squared is equal to 6, and 6 raised to the first is simply 6. So it would stay 6 the same also. All right, so moving along, we're going to take the square root of 64, and we're going to cube it. So the square root of 64 is 8, but then when we cube it, we end up with 512. Hope you guys are hanging in there. And then here, we're going to take the cube root this time, right? Because the denominator is a 3 of 125. And once we do that, we're going to raise it to the 4th power. So the cube root of 125 is 5. We raise it to the 4th power, and we get 625 as our answer. Rationalizing the denominator. I don't know why this is one of my favorite things. I'm not quite sure why I love to rationalize the denominator. So we can't have a radical on the bottom. So we've got to multiply both the top and the bottom by rad 5, which is going to give us 3 rad 5 over 5. And there's nothing here that can be simplified. So that's simply our answer, 3 rad 5 over 5. And now to our last page, number 16. Again, we can't have a radical on the bottom. So we multiply by rad 3 and multiply by rad 3, and we end up with 7 rad 6 over 3. Still nothing can be simplified, so that's our answer, 7 rad 6 over 3. Okay, this time it kind of looks the same, right? It's got all the same numbers here, but things are a little different. So what we're going to do is we're going to multiply both the top and the bottom by rad 6, and we're going to get rad 42 on top, and we're going to get 3 times 6, because rad 6 times rad 6 is 6 on the bottom. And 3 times rad 6 is 18. Rad 42, you cannot simplify it. So it simply just stays rad 42 over, goodness, I'm like talking and writing and making all sorts of mistakes. Rad 42 over 18. Here is something we can actually simplify. They're both in radicals, so we can mess with them. So I am going to reduce them both by 6. All right, well, rad 6 divided by rad 6 would simply be 2. And rad 18 divided by rad 6 would be rad 3. So we end up with 2 over rad 3. Oops, which we cannot have. So I'm going to multiply both the top and the bottom by rad 3, which would be 2 rad 3 over 3. And nothing can be simplified, so that's our answer, 2 rad 3 over 3. Okay, we're factoring here. This is equal to 1, right? So I can just do my x factor. I don't have to worry about splitting the middle term. Negative 24, and the middle brother that nobody likes moves to the bottom. What multiplies to negative 24 and adds to negative 5 would be negative 8 and 3. So I can just take these two factors and put them in my parentheses, x minus 8 and x plus 3. Now I have a number here, so it's a little bit different. I've got to multiply those two, and I end up with negative 56. I still bring the middle brother down to the bottom, negative 1. And what multiplies to negative 56 and adds to negative 1 is a negative 8 and a 7. So now I get to split the middle term. I bring down that 2x squared minus 8x plus 7x minus 28. Remember, I'm using the last term and the first term, and I've split the middle term. And now I factor by grouping. So I divide this by 2x, and I'm left with an x minus 4. And I divide this by 7, and I'm left with an x minus 4. My parentheses are matchy-matchy, so I know I did it correctly. I have 2x plus 7 for one, and x minus 4 for my other one. Here, hopefully you guys see it. There's a GCF. So I would factor out that x that they all have in common. My GCF is in x. And I would be left with 5x squared minus 11x minus 12. And now I can factor that just like I did number 20. So 5 and negative 12 would be negative 60. I'd bring the middle brother, nobody likes, to the bottom. What multiplies to 60 and adds to negative 11 would be negative 15 and 4. And I'd be left with 5x squared minus 15x from here plus 4x from here, and then minus 12, this part right here, that term. And then I go ahead and factor by grouping. So I see that my GCF is a 5x. I'm left with an x minus 3. And I see that my GCF here is a 4, and I'm left with an x minus 3. So now my matchy-matchy parentheses are right. I could go ahead and do 5x plus 4 for one, and my matchy-matchy x minus 3 for the other. And that is the end of your study guide. So guys, remember, office hours will be Tuesday from, 12:30 to 1:30. So show up if you have questions, please, or just to check in, whatever floats your boat. And I hope you are doing well. Talk to you soon. Bye.